So in this problem, they say find the electrostatic energy of 8 equal charges, 3 microcoulombs each, fixed at the corners of a cube of side 2 centimeters. Okay, so let's draw a cube. The sides are 2 centimeters. Okay, so there's the cube, and there are charges, all positive charges at the corners of the cube. Okay, so here's the problem. The electrostatic potential of 8 equal charges. So the electrostatic potential energy is between these two pairs, these two pairs, these two pairs, these two pairs, these two pairs. Every independent pair, you have to calculate all of that. Okay. Now you'll need the following distances. Well, this distance is already given, but you'll need this diagonal distance and that diagonal distance. Okay. So this is A. Let's calculate this diagonal distance. What is that distance going to be? We'll call it D1, and we'll call this diagonal distance D2. D1 square is equal to A square plus A square. So D1 is, okay, D2 square is this, okay, this is going to be D1. Okay, so you can see that D2 square is D1 square plus A square. This is also A. So D2 square is 2A square plus A square equal to 3A square. So D2 is root of A. D1 is square root of 2 times A, and D2 is that. Okay. All right, now let's add the pairs. Okay, so here's this pair. We'll have to add all the independent pairs. So on this face, how many pairs do you have with this distance? A. 1, 2, 3, 4. 4 pairs, and then you have 6 faces to the cube. Everybody understand that? All right, so let's do this. So let's draw another cube. Okay, so the potential energy is potential energy of all independent pairs. Okay. All right, so you have 4 pairs with KQ square with distance A, and 6 times 4, 4 pairs per face, and 6 faces, and each pair has that potential energy. Okay, so that's the potential energy with this distance. Now let's calculate the potential energy with this distance, d1. Okay, so plus kq square with distance d1. How many do you have per phase? 1, 2 independent pairs. Okay, so 2 of those guys, and then you have 6 faces. Okay. Plus, now you have to calculate the potential energy between these pairs. Okay, and how many of those pairs do you have? 1, 2, 3. You should have 4. 4. Okay, 1 from each of these to the opposite corner. Okay, so 4 times kq squared d2. All right, so the total potential energy is I'm going to that's 24 times kq squared by A plus 12 times kq squared, and d1 was root 2A plus 4 times kq squared, d2 was root 3A. Okay, so the potential energy works out to kq squared by A times 24 plus 12 root 2 plus 4 root 3. Okay. And if you want to simplify this further, 6 times 6 root 2 plus 4. Okay. So there is the total potential energy of that. Okay. And if you want, oops, what happened, my friend? All right, so if you wanted to put in the numbers, you can. I'm not going to put in the numbers. You guys can do that. All right. Yeah, you guys can do that. 3 microcoulombs. And A is 2 centimeters. Okay, we'll put in the numbers. So potential energy is 9 times 10 to the 9 Newton meter square, coulomb square, 3 microcoulombs. A was 2 centimeters. (10 to the minus 2 meters) times this number, 24 plus . Okay, if you take care of powers of 10, that's 10 minus 12. That kills 2, so 10 minus 10, that kills that. 10 minus 1, so what you have is 0.9 times 9 divided by 2 into that number, 24 plus 6 root 2 plus 4 by 3 root 3. Okay, and this is potential energy, so that'll work out in joules. Okay.